Today we shall go through the operator precedence parsing. An operator precedence parser can be constructed from a grammar called an operator grammar. So if I need to perform an operator precedence parsing, my grammar has to be an operator grammar. Now what exactly an operator grammar is? If I have a grammar such that there are no productions that have an epsilon on the right hand side, or we don't have any productions as such that is having the two adjacent non-terminals. So these type of grammars we call it as an operator grammar. So it's a requisite that I need to have my grammar as an operator grammar. Now if I'm going to tell it with an example, considering this grammar, E can have the form of EAE, bracket of E minus of E ID, and A can have the form of plus minus asterisk. Now, if I consider this grammar is not an operator grammar. The reason is that at the right hand side we have two adjacent non-terminals, that is EAE, that is a non-terminal. So if I have two adjacent non-terminals, or else at the right hand side if I have any epsilon, then that type of grammars are not considered to be as an operator grammar. So what I would be doing it, I would be rewriting this grammar with a new set of productions as E can have the form of E plus E, E minus E, E into E divided by E exponentiation E minus of E unary and ID. Now both of these grammars represents the same set of inputs that can be passed. But the only difference is that we have transformed a non-operator grammar to an operator grammar. Now performing an operator precedence, we need to have some relations. In a layman language, we represent it as less than, equal to, and greater than. But in terms of an operator precedence, these relations are meant as A less than of B represents that A yields precedence to B, means B is having a higher precedence as compared to A. And if A and B both are having the same precedence, then we write down as A equal to B. And if A is having a higher precedence as compared to B, then we put it as greater than symbol, and we represent it as A takes precedence over B, means A has a precedence more as compared to B. This is one of an important concept that we need to understand for an operator precedence parsing. I repeat it, less than, equal to, greater than, where less than means A yields precedence to B, equal to means both are having the same precedence, whereas greater than B, it means that A takes precedence over B. Now there are some rules for putting these precedence relations. For example, if I am going to take two of the operators, that is theta 1 and theta 2, and I assume that theta 1 is having a higher precedence as compared to theta 2, then we write down as theta 1 greater than theta 2 and theta 2 is less than theta 1. For example, if I am going to take this theta 1 to be as an asterisk and theta 2 to be as plus, it means that asterisk is having a higher precedence compared to plus. Same way, plus is having a less precedence as compared to asterisk. So this input we would be taking it in terms of, for example, if I am going to consider for this as an input, it can be as theta 1 is having a higher precedence, so it would be ID multiplied by ID plus ID. So obviously the asterisk is having a higher precedence, so this would be the symbol that would be represented. For this case, if I am going to take an input, that is ID plus ID into ID, so into is going to be the second of the operator, so this would be the having a higher precedence. Same way, if I am going to take with two of the operators theta 1 theta 2 and both of them are going to be of the same precedence, for example plus and plus, so how I would be representing is ID1 plus ID1 plus ID. So if I am going to take it as ID plus ID, both of the plus are of the same precedence, then we would be representing if it's going to be a left associative, and if it is a right associative, then the symbol would be representing as less than. So greater than for representing it to be as a same precedence left associative, less than for representing a right associative. Same way you will be continuing for the other examples also. If I am going to consider a theta with an id, the id would be having a higher precedence. For example, if I am going to take id plus id, means id, it's going to be a terminal. I need to replace it, that is the right hand side of the production, to be replaced by the left hand side. So how it would be, e can have the form of id. So it means that if I need to reduce to e plus e, I need to take that e plus e. So it means that first I need to reduce id to e, and then the next id also to e, then only I can reduce e plus e to e. That's why the id would be always having a higher precedence. Id would be having always a higher precedence compared to any of the operators. Same way, if I am going to take with any of a binary operator compared with an bracket, that is an opening bracket, obviously the opening bracket would be having a higher precedence because the brackets are going to be solved first. Same way, if I am going to have any of an operator that is within any bracket, then the operator would be solved first. In the same way, we are going to have with a dollar sign, dollar is going to be an end marker. So obviously, if I am going to take with any of an operator that is e plus e, and then if I am going to compare with a dollar, that is a right end marker, so obviously the operator would be solved first. This all things we shall be continuing with a set of examples also. So what I have told you over here, it's going to be the same way. For example, id plus id into id, so id would be solved first, so id would be having a higher precedence compared to plus. Same way, if I am going to take this id would be having a higher precedence compared to this plus. Same way, this id would be having a higher precedence to asterisk. First this id would be solved to e, that would be reduced to e because id would be first of the handle. And once this id is going to be reduced, then we would be reducing the asterisk as per the precedence, then we would be solving the id. This is how actually the operator precedence works. Now we shall see it with an example that how it does. Now if I am going to take for an example, that is the same grammar, that is an operator grammar. E can have the form of e plus e minus e, e into e, because it's an operator grammar, because we don't have any two non-terminals that is adjacent. At the same time, we don't have any epsilon at the right hand side of the production. The exponentiation is having a higher precedence and it's going to be a right associative, that we have discussed it right now. Asterisk and division are of the next higher precedence and both the operators are left associative. And plus and minus are also of the lowest precedence and again it's going to be a left associative. So it means to say that if I am going to take it as a plus b minus c, it means that a plus b would be solved first and then it would be minus, because plus and minus is of the same precedence, and plus and minus is going to be a left associative, so plus would be solved first. If you have a table entries to be as blanks, it means that there are error entries. So that error entries it represents while we are performing a parsing as an example. Now this is how the table is going to be constructed. Now these are representing the symbols in my given grammar. So if I am going to take it as a very small grammar, that is e can have the form of e plus e can have the form of e into e, and e can have the form of id. Only three productions I have taken. I repeat it, e can have the form of e plus e can have the form of e into e, and e can have the form of id. If this is the production that I have used, means I have terminal symbols as id plus an asterisk. id plus an asterisk. This is with the right, left and the right end markers. This is the left end marker and this is the right end marker. So this id and id, so how I am going to represent this one, that is the left hand side of the input and this is going to be the right hand side of the input. This complete represents the right hand side and this complete represents the left hand side. For example, in the last slide which I have taken it, for example, id plus id into id. So this is id, this is also an id, this is representing the left hand side and this is representing the right hand side, left and right. So this is going to be id that you are comparing it with plus. So if I am going to make it in terms of a table, how it would be, id you are comparing it with plus, id comparing with plus. So id would be always having a higher precedence, already we have seen it. Id would be having always a higher precedence, so you will be putting a higher precedence for id. Same way, if I am going to compare with id with an asterisk, or the id would be having a higher precedence. Id compared with the right end marker, id would be having a higher precedence. So in the same manner we would be continuing. For plus, we would be comparing with ID. So if I am going to plus compare with an ID, ID would be having a higher precedence. If I am going to compare with a plus and plus, this is going to be the left hand side of the plus and this is going to be the right hand side of the plus. Both are going to be of the same, corresponding precedence. So obviously it would be as a left associative. So this plus would be having a higher precedence as compared to this plus. If I am going to take with an asterisk, that is going to be compared with plus. This is going to be the left hand side and this is going to be the right hand side of the input. So this is going to be solved first. So obviously the asterisk would be having a higher precedence. That's why we are putting it with an asterisk. I have put some examples over here. For example, x plus y plus z. X, y and z, obviously it was an ID that we have solved it. So what is remaining now? Operators, that is plus and plus. So if I am going to take this plus and plus, based on the left associative, this plus would be solved first. So this plus and plus, the left hand side plus would be solved first. So this would be having a higher precedence, so we will be putting a greater than sign. You can see it over here. Plus and plus, this left hand side would be solved first, that's why it would be greater than. If I am going to take another example, that is x multiplied by y plus z. Asterisk compared with plus. Asterisk is having a higher precedence, so obviously the greater than symbol would be for an asterisk in the left hand side. So this is going to be the asterisk compared with plus. Asterisk would be having a higher precedence. Same way, if I am going to take with an x plus y into z, this is going to be plus and this is going to be an asterisk that is at the right hand side. So plus compared with an asterisk at the right hand side, asterisk would be having a higher precedence. Now ID and ID we have put it as blank. The reason is that we can't have an input that is ID and ID. The reason is that ID would be reduced to E, this ID would also be reduced to E. It means that you would be having an input as E and E, and as per the operator grammar we can't have two adjacent non-terminals. Same way, if I am going to take with a dollar and a dollar, this is going to be the left hand side and this is going to be the right hand side. So obviously the left hand side would be having a higher precedence as compared to the right hand side. So we can put it to be as a blank, that is dollar and dollar, normally we put it to be as blank. It generally comes when we represent it in terms of an except conditions. So this is going to be an elaborate table for all the set of the operators that we have taken it. Let it be plus, minus, into, division, exponentiation, ID and so on. You may please understand that exponentiation is going to be as a right associative. If I am going to take with an exponentiation at the left hand side of the input and exponentiation at the right hand side and the left hand side of the input, obviously this would be representing it to be as a right associative, means the right hand side exponentiation would be having a higher precedence, whereas for all other operators it would be left associative, means the left hand side plus would be solved first. This is the basic difference that we need to remember for an operator precedence parsing table. At the same time, we need to check that opening bracket and a closing bracket, you will be having an equal to sign. For remaining all the operators, we don't have any equal to sign. At the same time, if I get with some of the other entries, for example, I am going to take it as opening bracket corresponding with another opening bracket. It means that the inner bracket would be solved first. So inner bracket would be having a higher precedence. Same way, if I am going to take with an closing bracket and an opening bracket, there won't be any entries. It would be blank. The representation of the blank, the reason is that we can't have an opening bracket and a closing bracket without an operator in between. So these are some of the conditions that we need to remember while we are making the entries for the operator precedence table. Now if I am going to take with the same set of instructions, now once we have completed this table, now my table is complete. Now what I would be doing it, I would be taking one simple example. The input string ID1 plus ID2 into ID3. If this is going to be my input, and now what I would be doing it, I would be inserting the precedence relations for the given input. For example, the left hand side you would be having a dollar and the right hand side also would be having a dollar. That are the end markers. So I would be comparing with dollar, I would be comparing with ID in my given table. So if I am going to compare with dollar and the corresponding ID, ID would be having a higher precedence. Let us consider an example, id1 plus id2 into id3. Now we shall put the precedence relation for this given input stream, putting a dollar sign, that is a left end marker at the left hand side of the input, and dollar, that is the right end marker at the right hand side of the input. Now if I am going to look at the precedence relations by the table that we have constructed, we can find dollar compare with id. So comparing the dollar with id, we find id is having a higher precedence, so I will be putting the relation between the dollar and the id1 as id1 having a higher precedence compared to dollar. Same way I would be comparing for id1 with plus, I would find id1 is having a higher precedence compared to the operator plus. Same manner, plus compare with id2, id2 would be having a higher precedence as compared with my table. Continuing in the same manner, I would find all the precedence relations for the given input. Now once I have put all the precedence relations, I would be following some basic principles to perform the parsing. I would be scanning the input from the left hand side till I encounter the first greater than symbol. Scan the input from the left hand side to encounter the first greater than. Once I find the greater than symbol, stop there, scan backward, get the first less than symbol. The symbol that is going to be in between the less than and the greater than symbol, it represents the handle. Now I would be reducing this handle by the production, appropriate production. In this case, if I take the production as E derives ID, means ID would be now replaced by capital E. I repeat it, I would be taking the input, putting the left and the right end marker with dollars. I would be looking to the table and I would be putting the precedence relations appropriate. Once I put the appropriate precedence relations, then I would start scanning the input from the left hand side, and I would scan from the left hand side to get the first greater than symbol. Once I get the first greater than symbol, stop there, scan backward to get the first less than symbol, and whatever I find between the first greater than and the less than symbol is representing the handle, and that would be reduced by the appropriate production, that is the right hand side would be replaced by the production left hand side. If in this case I find it as E derives ID, so means ID would be reduced to capital E. Now once I have replaced this ID by capital E, it would be dollar capital E plus ID into ID dollar. Again I would be putting the precedence relations for the same set of inputs. Now in this case I won't have any precedence relations for dollar comparing with E. The reason is that E is a non-terminal and we don't have the precedence relations for any non-terminal. So I would be putting it as dollar compare with plus, and plus would be having a higher precedence. And in the same way, putting the precedence relations, reducing it by the handle, and continue till I get the final accept input for the given input stream. Now if I am going to represent it with an algorithm, repeat forever, if dollar is on the top of the stack, if dollar is on the top of the stack and input also points to dollar, then return, means we have got the input to be passed. Else begin, let A be the topmost terminal symbol, let A be the topmost terminal symbol on the stack and B be the symbol pointed by the input IP. If A, that is the stack terminal, is going to be having a precedence less than compared with B, or A is going to be equal to B, that is an input, then begin push B, that is an input, would be pushed onto the stack. The B, that is an input, would be pushed onto the stack. Advance the input to point to the next input symbol now. End. And if it is going to be a greater than symbol, then we would be reducing it. If it is a greater than symbol, then we would be reducing it. Repeat it, pop the stack until the top stack terminal is related by less than symbol, so that we can shift it to the most recently popped. And if I am going to have any blank, it means that it would be an error. So this is how we are representing it in terms of an algorithm. Now the same algorithm that we have seen it over here, this is known as an operator precedence parsing algorithm, and this algorithm we would be explaining it with an example. Now going to the example, the same grammar, E can have the form of E plus E minus E into E and E divided by E, and let us take an input as ID plus ID into ID. Now I am going to represent it in the form of a stack representation, and I am going to explain it. So stack, I am going to take the top of the stack to be as my dollar sign, that is going to be the left hand side, that is an end marker, and this is at the right hand side end marker, that is dollar. Now I would be comparing stack, that is a topmost stack terminal, that is dollar, would be compared with ID. From my table, I may find that it's a greater than symbol for ID. So as per my algorithm that we have seen it, if it's going to be a less than symbol, I need to shift it. So I will be shifting it. Now once it has been shifted, the top of the stack is now ID, and I will be comparing this ID with plus. Once I am comparing with ID plus in my table, where ID is going to be the left hand side and ID is plus is going to be the right hand side. So if I am going to check it, for example, let us go through ID, that is left hand side, compare with plus. In the table, its ID is having a higher precedence. So what I would be putting it, I would be putting a greater than symbol. If it's going to be a greater than symbol, as per my algorithm, if it's going to be a greater than, it means that I need to reduce it. So what I would be doing it, I would be reducing it. Reduce means ID would be reduced by the left hand side of my grammar symbol. So what's going to be as E derives ID, means this ID would be now reduced to E. So in the next step I have reduced it to E. I don't need to put it actually. The reason is that it's going to be a non-terminal, and for an operator precedence we never compare with any non-terminal symbols. So I can put it as blank also. It doesn't put any reason or meaning for that one. So if I'm going to take with as dollar, now I would be having dollar at the top of the stack, because E is not going to be compared because it's a non-terminal. So dollar compare with plus. Plus would be having a higher precedence. So again shifted with plus. Now plus would be compared with ID. ID is having a higher precedence as per the table entry. So next step ID would be shifted. Now ID would be compared with asterisk. So next step I find that ID is having a higher precedence. So obviously ID would be now reduced to E. Now it's actually dollar E plus E. Now E we are not putting it. The reason I have told you, it's going to be a non-terminal, so it doesn't make any sense to put it. Now this plus is going to compare with asterisk. Asterisk is having a higher precedence, so you shift it. Now next step ID would also be shifted. Now ID would be reduced. Now I would be comparing with asterisk compared with dollar in the table. Asterisk would be having a higher precedence, so it means that asterisk means it's going to be E into E. E asterisk E. So as per my grammar, E into E, that would be my handle. So it would be reduced to capital E. So it would be now E plus E would be remaining. Now E plus E, as per my grammar, it would be reduced to capital E. So it would be dollar at the top of the stack and dollar at the input. It means that it would be an except state. So this is how we need to perform the operator precedence passing algorithm. So if I conclude with an operator precedence passing algorithm, what all things we need to remember is, the first and the foremost, that a grammar should be an operator grammar, means the right hand side of the production should not have an epsilon. At the same time, it should not have any two non-adjacent non-terminals. Secondly, what I need to remember is that three precedence relations, that is less than, greater than, and equal to, where less than A, less than B, it represents that A yields precedence to B. A equal to B means both are having of the same precedence, where A greater than B means A takes precedence over B. Next step, based on these precedence relations, I need to prepare a table. I need to construct a table, and as per the rules that we have already seen it, we need to put the precedence relations, that is the left hand side and the right hand side input. Now after I am going to construct my table based on the precedence algorithm that we have seen it, let us take with an example as we have seen it over here, and we can perform the parsing and check whether the input is going to be passed or not. I hope that with this the operator precedence passing might be clear too. So thank you very much.